Which equation represents the function whose data is shown in the table? This is what number 16 asks. We have 4 equations. We have slopes of 1 and 2 for our equations, and we have y-intercepts of 1 and -1. If we go to our table, we see our y-intercept, which is where x is 0, is -1. So I know that I can get rid of the y-intercept of +1, which means this equation and this equation are still possible. So A and B are no longer a possibility. Now I decide or determine the slope for the line. The change from 1 to 2 is to add 1. The change from 1 to 3 is to add 2. The change in y over the change in x is 2 over 1, which equals 2. So my equation with a slope of 2 and a y-intercept of -1 is D. Question 17 says which of the following is nonlinear, which means it does not have a constant rate of change. It can have a variable raised to a power. It can have multiplied variables, and it can have a variable in the denominator. So if we look at the change on the x and y for B, we see that it changes 2 across the top and 8 across the bottom. For the other table, we have a change of 1 across the top and 1, 3, 5, and 7, which is not constant across the bottom. The other two choices are linear equations that we've seen many times. Therefore, we know those are not nonlinear. So my only choice that does not have a constant rate of change is answer choice C. Number 18 says which of the following is linear. Therefore, we want it to have a constant rate of change or slope. No variable will have exponents. No variable will be in the denominator. And of course, no variable will be multiplied. So if we look at these, the change across the top is a change of 2 on each one. Across the bottom is a change of 4, 12, and 20. That's not constant, therefore this is not linear. This has a slope of 1/3. The x is in the numerator, not the denominator, so that is linear. But let's go ahead and check the others. C has an exponent, which means it's not linear. And D has a variable in the denominator of the fraction, which makes that nonlinear. So my linear function is B. Number 19. Kyle wants to find the equation of the line that passes through the points 1, -7 and -1, 1. Which set of calculations will help Kyle find the equation of the line? Well, we know the equation of a line can be written as y equals mx plus b, where m is the slope and b is the y-intercept. And that looks like that's the way they've got these written. It also shows how to find the slope. We just have to figure out which way is correct. So I took the points that they gave us and I put them into a table, or I used the equation, the formula y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, which would give me 1 minus -7 over -1 minus 1. If we simplify those, the double negatives with the 7 tell us 1 plus 7 is 8. -1 plus -1, or a -1 minus 1, is -2. 8 divided by -2 is -4. So if we come over here, -4 is the answer we got, so A and B are not possible. Now I just have to figure out which one is y, that goes in the place of the y in this equation? Well, if I look at the ordered pair, 1, -7, -7 is my y value. Therefore, this equation has the -7 in the right place, and if we double check, the 1 is in the x values place because 1 is the x. Therefore, D is not the answer, and C is correct. Question 20 asks for the equation that contains the points 5, 3, and 2, 6. If we use y sub 2 minus y sub 1 over x sub 2 minus x sub 1, we find the slope to be 3 over -3, which is -1. C and D have a -1 slope. A and B do not. If we substitute the ordered pair 5, 3 into each of these two possible equations, 3 being the y and 5 being the x, the only one that is correct is C, because -5 plus 8 is 3. -5, -8 is -13, so this is not correct. Samantha charges an initial fee plus an hourly fee to repair computers. The table below shows the amount Sam charges for the first 3 hours of repair. What amount does Sam charge per hour? In other words, we want the slope or the rate of change for the table. Well, we have an increase of 25 for each hour of work. Therefore, Sam charges $25 per hour. 22 says that we have a cylindrical container that has a radius of 4 centimeters and a height of 24 centimeters. What is closest to the maximum number of cubic centimeters the container will hold, which is asking us to find volume. So we substitute 3.14 for pi, 4 squared for the radius squared, and 24 for h. We type that into the calculator, and we get 1,205 and 76/100ths. But it says to the closest maximum number. So if we round this, the volume would be approximately 1,206 cubic inches, or centimeters, excuse me. Shows us a graph with the display of a relation between x and y in the graph. Why does this relation not define what as a function of x? This relation is not a function of x because there is at least one input, or x value, with multiple outputs, or y values. If we come over here, 1 has an output of 4, 2 has an output of 2, but 3 has an output of both 2 and 3. So the ordered pairs 3, 2 and 3, 3 make this not be a function. Question 24 asks, what is the number of solutions for this system of equations? This system of equations cross or intersect one time. Therefore, this system has exactly one solution. And if we name that solution, it would be the point 3, -2. Number 25 asks us to find the solution for the system below, which means we have to find an x and a y. Our equations are 2x minus y equals 5 and x minus y equals -4. I'm going to rearrange the bottom equation to substitute. If I add y to both sides of the bottom equation, I get x equals -4 plus y. Now I can substitute this negative 4 plus y in place of the x in this equation. When I substitute negative 4 plus y into this equation for the x, I get 2 parentheses, negative 4 plus y, close parentheses, minus y equals 5. Let's solve. Distributive property first. When I multiply, I get negative 8 and plus 2y minus y, bringing down the minus y equals 5. Now let's add like terms. The 2y and the negative y are like terms. Therefore, when I put them together, I get negative 8 plus 1y equals 5. Now let's solve for y. When I add 8 to both sides, turns out y equals 13. Now I'll come back to my changed equation where I found what x was equal to and substitute 13 for y. Negative 4 plus 13 is 9. So my solution to this equation is the ordered pair, x first, y second, 9, 13. Next we'll solve the equation, but it asks me, or I'm going to ask you, how many solutions will this equation have? Is it special? Is it going to have one solution? If it was, my coefficients would be different on my variable. So no, it does not have just one solution. Well, that leaves two choices. My variables are identical, so therefore it could be either infinite or none. But I noticed that my constants are different. If my variables are identical, but my constants are different, it can't be infinite solutions because they would have to be identical to be infinite. Therefore, this equation has no solutions. Remember, one solution has different coefficients with the variable. An infinite solution is identical variable and constants, although it could be a multiple. And none has different constants. 27 asks, why do the following equations have infinite number of solutions? We said they had to be identical, or that could be with a multiple that makes them identical. So let's see. I have 4 and x and 8x. I have 6y and 12y. I have 18 and 36. Well, if I were to take 4 times 2, I get 8. So 8 divided by 2 is 4. What if I divide 12 by 2? That would be 6y. So this would be 4x. This would be 6y. Well, what's 36 divided by 2? That would be 18. What do you notice about these two equations? Now that I've taken the multiple out of them, this equation is identical to the first equation. Therefore, this is why they have infinite solutions. The equations have infinite solutions because they are multiples of the exact same equation. 28 has us solving the equation for x. First, we'll do distributive property. When we multiply everything on the right side by 4, we get 12x minus 24. Now we'll move the variables. I'm going to move the 3x because it's smaller. When I subtract 3x from both sides, I am left with 11 equal to 12 minus 3x is 9x minus 24. Now I'm going to move the constant of 24 by adding it to both sides. When I add the 24 to both sides, I get 35 is equal to 9x. Now we divide both sides by 9. 9 does not divide 35 evenly, so we get x is equal to 35 ninths. If I wanted to change it to a mixed number, I could, but that's not necessary. Number 29 asks us to write each of these with a single exponent. 1 over 10 is actually 10 to the negative 1 power, and there happens to be 3 of those. So if I have 10 to the negative 1 power times 10 to the negative 1 power times 10 to the negative 1 power, I add my exponents and I get 10 to the negative 3 power. On B, I'm going to do it a little differently. I have 1 over 10 to the 1, 2, 3, 4, 5, 6, 7th power. And if I could leave it like that, or if I want to bring my 10 to the numerator, my exponent goes from the denominator to the numerator. It becomes the opposite, which means I have 10 to the negative 7th power. Either of these answers is correct. On C, inside the parentheses, I have 10 to the negative 4th power. As we know, 1 over 10 is 10 to the negative 1st power, and there's 4 of them. But I have that squared. When I have a power raised to a power, I simply multiply my exponents, so that gives me 10 to the negative 8th power. D would work the same way, or I could do 1 over 10 to the 3rd power raised to the 3rd power, which would give me 1 over 10 to the 9th power. If I want to move the base to the top, then my exponent becomes the opposite. In this case, the positive 9 becomes negative 9, and therefore we get 10 to the negative 9th power. On the last one, we have 10 3 times inside raised to the negative 2 power. When we multiply those power to a power, we get 10 to the negative 6 power. If we want to write this with a positive exponent, then we simply move the base, change the power to the opposite, and take the reciprocal by putting 1 over 10 to the 6th power. 30 says select all the expressions that are equal to 4 times 10 to the negative 3rd power. Well, 10 to the negative 3rd is 1 over 10 to the 3rd power, or 4 over 1,000, because 10 to the 3rd power is 1,000, or 4 thousandths, which I could do by making my exponent go up and my number get smaller, which would give me 4 thousandths either way. So let's look. Do I have 4 thousandths here? Well, this is 4 10 thousandths, so F is out, but E is 4 thousandths. I have 4 times 1 10,000th. Well, that would be 4 thousandths, so that is not the answer. But 4 times 1,000th, like we have here, would be equal. Then I have 4 times negative 10, times negative 10 times negative 10. 10 to the negative 3 power is not negative 10. This is not the same. But 1 over 10 to the 3rd is 1 over 10 times 1 over 10 times 1 over 10. Therefore, A would also be equivalent. Question 31 says the cost of Jake's cell phone bill is determined by how many megabytes of data he uses each month, as shown in the graph below. If we notice that the initial cost, or the y-intercept here, is $40 that he pays each month, then it increases to 50 for 5 megabytes of data. So we've got the increase of 10 from 40 to 50 over 5, $10 for 5 megabytes, which gives me $2 per megabyte of data, which actually is my slope or rate of change. So if I'm looking at the equations, the one that has the slope of 2 and the y-intercept of 40 is what I'm looking for. This has a y-intercept of 40, but not a slope of 2. This one has a slope of 2 and a y-intercept of 40, so this must be my equation. This has a slope of 40 and a y-intercept of 1/2. That's not what we were looking for. And this has a slope of 40, not what we were looking for, and an intercept of 2. It definitely does not intercept at 2. So my equation is y equals 2x plus 40. Sorry, you couldn't see that. I looked for my slope and then my y-intercept. These both had the y-intercept, but the only one that had the slope was B. Question 32 says, which system of equation has no solution? I have gone through and eliminated any multiples. If I divide by 2 here, I end up with the same equation. If I have the same equation on the first half, but my constants are different. Here, when I divide by -1, I end up with the same equation, 2x minus y equals -11. And here, if I divide by 3, I get x plus 2y, which is not the same, is equal to 1/3. So these equations are not identical at all. So now I have to decide which one has no solution. Well, just like before, if they're identical, even if they are multiples, they are not. They have infinite solutions. So both of these have infinite solutions. So A and C are out. This one, where our variables with their coefficients are not the same, has one solution. So obviously, it's out. Well, that leaves me the system that is identical variables but different constants. That makes it have no solution. So it is answer choice B. We have 3 questions left. We need to stop here so you can solve those, and we can check them after you've finished. Question 33 says 2 solids are described in the list below. One solid is a sphere with a radius of 6 inches. The other solid is a cylinder with a radius of 6 and a height of 6 inches. What is the difference between the volume in cubic inches of the solids? Using my formulas, I plug in the numbers that it gives me. 4/3 times 3.14 for pi times 6 to the 3rd power. And for the cylinder, 3.14 for pi, the radius is 6 squared, the height is also 6, and we multiply. The volume of the sphere turns out to be 904 32/100 cubic inches. The volume of the cylinder turns out to be 678 24/100 cubic inches. But it asks me to find the difference. To find the difference, we subtract 904 32/100 minus the 678 24/100 and get a difference of 226 800 cubic inches. But we're not through because we have not truly answered this question. because likely this would be a written answer. So I would write the difference between the volumes of the sphere and cylinder is 226 and 800 inches cubed, and the sphere is larger. Just because I want them to know I understand. 34 says 2 students, Matt and Billy, each calculated the volume of a spherical ball with a diameter of 15 centimeters. Their work is shown below. If I look at Matt's work and I look at Billy's work, I see a difference in this number. Matt did not take the diameter and divide by 2. Billy, however, did take the 15-inch diameter or 15 centimeter diameter and divide by 2 and get 7.5 centimeters. That is what is the difference between the two students. So I need to answer this now. So I write my statement to explain my answer. Matt made the error. He did not divide the diameter to get the length of the radius to use in the formula. Therefore, his solution is incorrect. We will work this constructed task together.